Welcome to chapter 3.7 on Pure 2, which we continue our lesson on sequence and series. Now, over the last very many lessons, we talk about different type of series and sequences. We talk about arithmetic, we talk about geometric, and then last lesson or last video in 3.6, we talk about the sigma notation. So they all represent sort of different types of sequence and series because not all types of sequence series has followed the same, you know, rule. So, for example, arithmetic, they add or subtract the same number. Geometric, they multiply, by the same number. Sigma notation, you've got nth term and you have to follow the nth term. However, not all sequences series follow a particular structure like adding or multiplying the same number. So in this one, how about if you think about, if you remember Fibonacci sequence, that's a very famous sequence that does not follow a geometric or arithmetic. If you can't remember what's a Fibonacci sequence is a one, and a one. So you add the front two numbers together, one and one plus two equals two. One plus two is three. Two plus three is five. Three plus five is eight. Right? So that's a very famous sequence, Fibonacci sequence. Now, if you actually don't know Fibonacci sequence, I just suggest you Google it. What you also call the golden ratio, which actually applies into photography or art. Something quite strange, how math could apply to art. But that's something, if you're interested, you can Google a bit more. I don't know anything about art. So all I know is golden ratio, and that's all I know. Okay, so if you're interested, actually, they do apply what a good art or what a good structure of art, etc. ratio does has something to do with Fibonacci sequence. Weird, isn't it? Right. So in this lesson, we talk about recurrence relations. So what is that? Now, position to term sequence, what we've been learning so far, is called like the nth, sort of the nth term. So un equals 2n squared plus 3. So this is what we call position to term. It tells you, okay, it tells you the value of each position of the sequence, depending on the value of n. So if you let n equals 1, you get the first term equals to 5. If you put n equals 2, then your answer, the second term will be 8. So you can see, is it 8? No, 11, I think. 2, 4, 8. Yeah, sorry. Quick mental maths, 11. So what this one position to term sequence tells you that depending on value of n, it tells you the value of the position. All right. Now, term to term sequence, which is what we're looking at today, also known as recurrence relation, okay, is like, for example, un plus 1 equals un plus 5. The plus 5 is not underneath the n, okay? So it tells you the value of the next position in the sequence. So un plus 1 un. So what's the relationship? What's the recurrence relationship between them? Well, un is like the previous term. And the un plus 1, okay, un plus 1 is the next term. Right? So what this tells you is the next term equals to previous term plus 5. So it depends on the value of n. If n is 1, that means the first term, that means u1, the first term plus 5 give you the u2, the second term. Okay? Now, if we look at Fibonacci sequence, okay, Fibonacci sequence is actually quite simple in that regard. Essentially, is this what it means is if we start looking at the third term, so un plus 2 equals to un plus un plus 1. That's Fibonacci sequence. What does that mean? Well, that means the first term plus the term after the first term, which is second term, equals to the third term. So if n, let's say if n equals 1, if n equals 1, then un plus 2 becomes u3 will equals to u1 plus u2. So that's the first term plus the second term equals to the third term. Okay, I use different color. If n equals 2, if n equals 2, u2 plus 2 is u4. u4 equals to u2 plus u3. That means the second term plus the third term equals the fourth term. So you can see now how this is different to arithmetic or geometric or summation sign, the sigma notation. Sorry, summation also is known as sigma notation 3.6. This sigma or summation, sigma or summation. Because this does not rely on a generic n term, right? It does not rely on like 2n squared plus 3. There's no fixed structure on the term by term rule. But this one is a recurrence relation, means it based on the previous terms. Okay, so that confuses a lot of students about, okay, what's the difference, what we've learned before to this one. They do not understand, actually, we're talking about two different types of sequences. Okay, right, so let's have a look in this one. Important note, with recurrence relationships questions, the sequence will likely not be arithmetic nor geometric. As I mentioned, they are very different type of sequence or series. Okay, so your previous UN and SN formula do not apply, right? So let's have a look. Example, right? Example. So UN, question A, find the first four terms of the following sequences. UN plus 1 equals UN plus 4. U1 equals 7. This tells you the first term equals 7. U1 means first term, all right? So this sequence tells you to do, okay, so the next term equals to the previous term plus 4. Right, so we're given the first term. That means if we'll find the next term, u2 will equal to u1 plus 4, which is 7 plus 4, 11. If I want to work out u3, which is the previous term, u2 plus 4, which is 11 plus 4, 15. Okay, u4, which is u3 plus 4, which is 15 plus 4, which is 19. Now, this sequence, however, is a arithmetic sequence. You can see we're adding 4 each time, but it's not always arithmetic. Okay. Next one. What about the first 4 terms in this one? You might want to have a go if you want to try it yourself. Actually, it's quite a simple one, where this time u2 equals to u1 plus 4, which is 5 plus 4, which is 9. u3 is u2 plus 4 again. Oh, it's the same question. 9 plus 4, which is 13. u4 will be 17. So 13 plus 4. Okay, for the first 4 terms. Right. So example, next one, we'll go on to look at something a bit harder, okay, more like exam question in here where we have a lot of letters and we have to understand what's going on. A sequence, A1, A2, A3, that means A1 is the first term. Now you need to be able to understand what's going on here. That's the first term, second term, and third term. Now notice the 3 tells you the position of a term. It doesn't tell you the value of a term, it tells you the position of a term. Okay, now A1 equals P. It means first term is P. You need to be able to understand what's going on in the question, okay? Sort of tell yourself these kind of wordings in the exam, because then it tells your brain, okay, I know what to do now. An plus 1 means the next term equals the previous term squared minus 1. And this sequence only works when n is greater or equals to 1. You're also told p is less than 0. Okay, show that a3 equals p to the power 4 minus 2p squared. To find a3, okay, to find a3, using this recurrence relation, we know to find a3, we need a2. But we don't have a2, so we need to find a2. Okay, so I'll write it down in here for you. Okay, so to find a3, we need a2. So to find a2, we use a1. Okay, so that's our target. We need to find a2 first. So what's a2? a2 equals to, using this recurrence relation, a2 equals a1 squared minus 1. So the next term equals to the first term squared minus 1. So a2 equals p squared minus 1. Next, what about a3? So a3 equals to, by the way, actually there's a very bad habit of writing it. In exam, you should never write parallel. I'm going to write that underneath in here. You should follow the order from top to bottom, so the examiner can follow what you're writing. Okay, so a3 equals to the previous term, now a2 squared minus 1. So a3 equal, I keep telling students, always write a left-hand side. If there's a left-hand side, right-hand side, always keep a left-hand side, because it tells not only you, also examiner, but also your brain, what this equation is for. Okay, you work on A3. So A3 is A2 squared, which is P squared minus 1 squared minus 1. Expand the bracket. So P squared is P to the power 4. P squared times 1 is P squared. Time, double it is 2P squared. Minus 1 squared is 1. And then subtract the 1. So A3 equals to P to the power 4 minus 2P squared. Proven. Part A. Part B. Given that A2 is 0. Given that A2 equals 0, well, you read this, you find your A2. Okay, I found my A2, which is here. So P squared minus 1 equals 0. P squared equals 1. P equal. Now, a lot of students would have put just 1 in there. But actually, that's incorrect. Because if you remember, if you in square root, you have plus 1 or minus 1. And in fact, this question is quite cheeky. They tell you P is less than 0. Therefore, you should reject that one. So P equals to minus 1. Right, I think this is an exam question, a previous exam question. Question C. Oh, summation sign. Okay, a sigma notation. Okay, let's have a quick recap on what does that mean. So, okay, now let's look at room by one. Okay, so if you need the notes on 3.6, go ahead and read it. Okay, but if you, okay, let's see if you remember what is the 5 components in the sigma notations for this one. So we've got the 200, we've got the summation, sigma, we've got the R equals 1, we've got the AR. So, sorry, 4 components. Okay, what are the 4 components for? So, let's do a quick recap. R equals 1 is starting value. AR is the sort of the nth term. Okay, and then 200 is the last term, ending value. Sigma means add them up. If you remember what I said in the 3.6 video, when it comes to sigma notation question, what you want to do is you want to write all the terms one by one. Okay, so what's the first term? Well, the first term is you sub in 1, R equals 1 in there. So the first term is A1. Second term, when 1 becomes 2, sub it in, A2. When R next term, A equals 3, sub it in, A3. So what you're doing is you're just replacing the value of R every time in each term. Okay, so I know, quick recap. I just want to make a random question. Okay, 2R plus 1. Okay, if you want to do a recap 3.6, you should. The first term in this one is 2 times 1 plus 1. Second term is 2 times 2 plus 1. Every time what you do is to find the next term, you just replace a bigger value of R. You just do the subsequent number of R. You sub it in, okay, to find the term. Okay, right, so plus dot dot dot, we are going up to 200, so A200. Now, you might be wondering, how do we do this? How do we work out A1, A2, A3, A4? That's a lot, isn't it? Well, usually there's a pattern. Okay, they're not going to ask you to work out every single of them. They're usually a pattern. So why don't we work out one by one? What's A1, A2, A3, etc. So A1, now we know P equals minus 1. So A1 was P. So A1 is P. So it's minus 1. A2 is P squared minus 1. So minus 1 squared, 1 minus 1 is 0. Put in a calculator, by the way. This is dangerous. Don't do mental maths. A3 is P to the power 4 minus 2P squared. Something minus 1 in there. You should get 1. 1 minus 2 times 1 is... why do I trust my mental maths? Just put in a calculator. Minus 1 to the power 4 minus 2 times 1, which is minus 1. Again. Okay, now you start to question, oh, is this pattern just repeating minus 1, 0, minus 1, 0, minus 1, 0? Well, if that's something you're thinking of, that's good. We need to verify it. Okay, so let's verify it by doing A4. So what's A4? We only go up to A3 in here, so how can we find A4? Back to the recurrence relation. Look at the question. They tell you the secret formula to find the next term. The formula is the next term equals to previous term squared minus 1. So it's the previous term. So A3 squared minus 1, which is minus 1 squared minus 1, which is actually indeed 0. So you can see the sequence actually go minus 1 plus 0 plus minus 1 plus 0 plus dot dot dot. So you're thinking, okay, obviously you can do it manually if you want to, minus 1 plus 0, but you can do a smarter way, which is think about from A1 to A200, how many minus 1s are there? Well, there are 100 lots of minus 1 because there will be 100 lots of minus 1 and 100 lots of 0. So you can put 100 times minus 1, which is minus 100. Now, this also the part student always find the most difficult. Okay. One, they struggle to understand what does the sigma notation mean. Okay. They struggle to find out the term by term. All right. And two, this question particularly harder because you also need to use recurrence relation from the question. Okay. To find out what actually A1, A2, A3 are. All right. This is a very typical exam question. Part D. Write down the value of A199. Well, A199. So you can see all the odd terms has a value of -1 because A2, A4, A6, A200 are all 0. So A199 part D, A199 must be -1. Okay. If you're happy with this, okay, pause the video, have a go at this exam question. Okay. When you're ready for the answer, you can press play. Well, here are the final answers. Okay, if you got it right, well done. Move on. But if you don't, let's have a look. Okay, question A. I think there is one more exam question if I remember correctly. Oh, actually, there are notes, so stay tuned. Anyway, so question A. Write an expression for A2 in terms of A. So this is a recurrence relation, tells you next term equals A times the first term or previous term plus 5. So x2 equals, let's rewrite A times x1 plus 5. So x2 equals A times 1 plus 5, which is just A plus 5. Okay, that's why it's 1 mark. Part B, show that x3 equals to that one. To find x3, we need to use x squared. So, sorry, x2, the second term. So A times x2 plus 5, which equals to A times A plus 5 plus 5. That's a really simple question. Expand the bracket, A squared plus 5A plus 5. Part C, given that x3 equals 41, well, you're told x3 is 41, so why stop straight away? Make this equals 41. Okay, I believe you can make it quadratic, so you should get a squared plus 5a minus 36 equals 0. As I mentioned that before, anything with quadratic, okay, you do not need to show how to factorize it. Okay, just put in a calculator. You don't get any marks for showing how to solve it. Use quadratic formula. We're not GCSE. Grow up. So it's -9 or 4. Okay, 3 marks, easy peasy. Right, next one. Okay, a sequence is increasing. Right, a sequence is increasing if. Now, I'll give you two sequences. You can easily tell me which one is increasing, which one is not increasing. Well, you can clearly tell. Hopefully, you do know the first one is increasing, right? How do you know? Because the number for the next term is bigger than the previous term. And decreasing means the second term is smaller than the first term, or the next term is smaller than the previous term. So increasing means the next term is greater than the previous term. Now, always remember, un plus 1, you can replace it verbally as next term, and un means the previous term. Okay, so that's how you can make sense of mathematical equation, is try to convert them into words. Yep, it's a difficult skill. Words, English, maths. A sequence is decreasing if the next term is actually smaller than the previous term. A sequence is periodic if the terms repeat in a cycle. The order of a sequence is an integer such that un plus 1 equals un. Well, in simple terms, in simple words, okay, simple words means how many terms in between a cycle. If you want to, you can use the previous example. You can refer back to this example here. Questions, okay, question C. Now, if you can look, -1 0, -1 0, -1 0. So this is a period of 2. Okay, so I'll give you give you a few examples in here. Okay, the first one is that, let's say, a 2, 3, 4, 5 is an increasing sequence or series. Actually, sequence. We're not adding them together. Sequence. Okay, -3, -6, -12 is a decreasing sequence. -2, -1, -2, -1 is a periodic sequence with order 2. Okay, I'll give you one more in here. -3, 6, 2, -6, -3, 6, 2. This is a periodic order 3. Hopefully that makes sense because 3, 3 is every, it's every chunks of 3. The cycle goes every 3. Okay. Last one. Okay. You could have not a decreasing, not increasing, not periodic. You can have one of them that is none of them. For example, I just make it up. 1 -2, 4 -3, 6 -5. So this is this is not increasing or decreasing or periodic. It's just a random sequence. Okay. Right. So any more example? Determine if the following sequences is increasing, decreasing, or periodic. If it is periodic, write down its order. So what I'll suggest you to do is, okay, I'll let you pause video actually. Can you write down, use the first few terms, okay, to see if they're increasing, decreasing. Write down the first few terms of each sequence. Okay, you can pause video, have a go. So you do want to write down the first few terms. So for example, U1 is 7, okay, for A. U2 is 7 plus 3. U3 is 10 plus 3. So we can see this clearly increasing. Okay. Question B. U1 is a half. So U1 is a half. U2 is a previous term squared. A half squared is a quarter. U3 is the previous term squared, 1/16. So we can see this is decreasing. Well, you guess it right. One increasing, one decreasing. The last one must be a periodic. C, but let's see why. Okay. Now we are not told the first term. Oh, special. Now let me write down UN equals sine 90 times n degree. So U1, when n is 1. Now when n is 1, that means you replace n is 1. So 90 times 1, sine 90 is 1. U2, sine 90 times 2, sine 180 degree is 0. U3, sine 90 times 3, sine 270 minus 1. Oh, special. U4 is sine 90 times 4, sine 360, which is back to a 1. Back to 0. U5, sine 90 times 5. So sine 450 degree is my imagination. Let me put in a calculator. Is 1. So we can see, and U6 you'll bet is 0. So it is a periodic sequence. Order, what's the order? It's every 4 that repeats. Okay, it's every 4 that it repeats. So the order is 4. Okay, I hope that makes sense. So I believe that will be actually the end of lesson